So if I just consider now the mechanism of current flow in a conductor, so which we call it as a drift velocity and your relaxation time. Yeah, so this is what we can talk about the drift velocity. Let's say this is nothing but the conductor which is at room temperature. I know that because of some thermal heat it has got some your energy, and the electron comes out of that your valence shell and it becomes free. But now they are just randomly moving in all possible directions. They are not moving in a particular direction, but they are just moving randomly everywhere. So you can say that even in this case, so if I say that there is no net flow of electron in a particular direction, so if the two electrons on an average they are moving towards the right side, let's say for example, so the two electrons are moving on the left side, so the net flow of electron is 0. Yeah, so this is what we can say. So now what you have to just make sure, so what is the drift velocity, so also we have to find out that also. So this is the initial velocity. Yeah, so this is u1 bar plus u2 bar up to let's say un bar upon n. Yeah, so this is the initial velocity which is having or which is associated with each electron, and the average for that obviously I just told you it is 0. Yeah, so the average for them is nothing but 0. Now I am just going to apply some external voltage across them. So what will happen because of that, so now all the electrons get drifted. Yeah, so obviously the electrons are now get attracted towards that positive terminal over here. So because definitely they have got some acceleration also, because of that they are having some initial velocity. Now they have got some additional velocity because of this potential difference. So now again we know that electric field intensity, yeah, so which we know that which is nothing but your force per unit charge. Okay, again acceleration, obviously we know that your force is equals to mass into acceleration. Acceleration is nothing but force upon, yes, so definitely mass, and this F is equals to Q into E. Yeah, so this is how we'll say that. So this is E upon m. Yeah, so this is E upon m. So this is how I can write it down, the acceleration for this. Yeah, so that is acceleration is E upon m, and since it is having the negative charge, so this is how now all of them will get accelerated towards your positive terminal. Fine. Now while just moving from one end to the another end, I just told you that they are going to collide with randomly. So right now, so let's say for example this electron which started its motion, but again meanwhile he just collide with another one. He has gained some velocity, but again after that he lost that velocity when the next collision occurs. Okay, initial there is some velocity. So how I will define that final velocity, that is a u1, and obviously that is a tau. So what is that tau? So tau is the relaxation time. So this tau we will call it as a relaxation time. So that is the average time between the two successive collisions. So that is how we can define the relaxation time over here. Yeah, obviously we can say that. So this is the relaxation time. So similarly we can say that v2 for another one, that is a into tau. Yeah, so this is a1 a2, likewise you can just write it down. Yeah, so this is okay. So how I can just write it down, all the electrons we just assume that they move with the almost constant acceleration. So this is how you can just find their final velocity in general. Yeah, so you have to just take the average for all of them, u1 plus u2 up to un upon n. Yeah, and then this is a, again this is tau mean. Yeah, so that is a mean average your relaxation time. So this is 0. Yeah, so again this a is nothing but that is a minus e upon m, and this is nothing but the tau. So this velocity we are going to call it as a drift velocity. Yeah, so this is what we will call as a drift velocity over here. So you can see that from this diagram also. Yeah, so when he just applied some electric field across it, so it just got drifted, it just get drifted from this b to b dash by some, that is what we can say about this is its original path, the one which I have shown by that dotted line. But now when we just apply that external field, so because of this electric field, just it has got drifted, and definitely what we will call as a drift velocity. Yeah, so initially obviously that electron is having some random velocity, but now we just apply some external potential, because of which all of them get drifted towards the positive terminal. So drift velocity also you can define as the velocity with which all the electrons get drifted towards the positive terminal is called as a drift velocity. And we have seen the expression for the same for this case also for this case.